It's being said more often lately that machine safety doesn't cost, it pays. This is because many machine safety tools are getting easier to use, risk assessments are simpler to do, and safety standards are harmonizing. As a result, machine safety is evolving from an obstacle into an opportunity. However, despite the usual lip service about its importance, too many manufacturers, from managers to operators, still view machine safety as a costly drag on production. And so, it's often ignored or bypassed, and the tragic, avoidable injuries and deaths that sometimes result are often rationalized as the cost of doing business. Fortunately, it's increasingly obvious that a little investment in machine safety now can pay back huge long-term dividends in reduced downtime and improved production. To track some of these trends, we recently polled close to 100 members of Control Design's audience to get a look at the types of machine safety methods and equipment now being used in their machines and applications. We've also asked Fred Hayes, Technical Services Director for the Packaging Machinery Manufacturers Institute, to join us to interpret those answers. Besides being PMMI's resident safety expert, Fred has worked as a machine builder for 28 years, mostly with cartoning equipment, and estimates he has been in close to 1,000 different manufacturing plants. Hi, Fred. Thanks for helping us out today.
Hi, Jim. I appreciate the opportunity to be here.
We'll begin right after this message. Well, let's get started. When asked to identify all the safety components on their machines, 93% of the respondents report having e-stop buttons, 74% have gate or door interlocks, and 62% have safety relays. But we also see that less than half, 48%, use programmable safety controllers and 42% employ light curtains. That matched up pretty well with the findings that 81% reported that their safety systems are hardwired, while only 19% say they use a digital network. Fred, does this reflect that there's still an unwillingness to use programmable safety controllers, a stubborn lack of knowledge about the ability to use them, or some combination of both? Are there applications for which a relay-based hardwired system really is preferable these days?
Well, I think the first thing you have to recognize is the fact that in the U.S., most machinery users use the National Fire Protection standard NFPA 79, which is for industrial machinery. Until the 2007 edition, that standard specifically said that you could not use a programmable device for a safety circuit. You had to use hardwire. So even though programmable systems were allowed in the European community, because the standards over there allowed it, they were not specifically allowed here. So a lot of the technology was developed in the EU, and once the standards had been changed here, then I think there was greater utilization of it.
We also asked the survey participants to tell us who decides what and how much safety equipment their machines need. As a result, 57% of the respondents say it's the machine builder's choice, 28% say the end customers choose, and 15% report that system integrators decide. Okay, Fred, from your viewpoint, are the machine builders being given more responsibility to make these decisions? Do liability issues enter into this decision-making?
Well, liability issues are always of concern, but I think primarily one of the things that has been driving a change is that many of the global users and manufacturers of machinery have been standardizing their control system specifications based on the need to meet the requirements for the CE marking under the European Machinery Safety Directive. Control circuit reliability is one of the essential health and safety requirements in Annex 1 of the Machinery Safety Directive. This refers specifically to a standard called EN 954 that talks about categories of safety circuits. A particular category defines the physical structure of a safety circuit. Most packaging machines are constructed using Category 3 structure, and that has in fact become kind of a de facto standard because many of the global consumer goods manufacturers, that's what they want. It doesn't make good business sense to buy and build one machinery for the EU and a different machine for the U.S. market. So the growth of many consumer goods manufacturers is outside of the United States. Therefore, it makes good business sense to approach machinery on a global basis. The machinery users many times will define the category, the safety circuit they want, but the machine designer has to actually engineer and design the circuit.
Next, this year's survey asked about the machine builder's biggest machine safety design headaches. 48% report that it's hard to know what standards and regulations to apply. 29% say their worst problem is that operators try to defeat the safety system that's installed, and 23% state that fully operational safety systems impede productivity. Well, it seems like there's a knowledge disconnect here. Let's start with standards. Particularly for a global machine builder, why is understanding the appropriate standards to use an issue for some of them?
Well, it's been an issue because in the European community, and this is based on the directive, which is a law, that in Europe, a machinery builder that's going to place a machine on the market and install it, they have to sign a declaration that their machine meets the essential health and safety requirements of the directive. One of the requirements is that you have to do a full risk assessment on the machine and have control circuit reliability, etc. In the packaging machinery industry, we've recognized this, that harmonization was really critical. So in 2006, PMMI took their safety standard and harmonized it with the requirements of the European directives and the European standards. I think as far as being a headache, one standard always references other documents, and if you aren't clear in terms of what documents you're referencing, this can be a problem. On the electric side, a lot of progress has been made in the last 5 years because the European standard for electrics for machine controls is called IEC 60204-1, and that standard now reads word for word, almost identical to the NFPA 79 standard used here in the United States for industrial machinery. So this was a big step forward in terms of harmonization for control circuits and electric controls in general on machinery based on these standards.
What about the age-old problem of operators trying to defeat the system? Is that just attributable to bad design when nearly a quarter of the respondents also think that safety impedes productivity?
On some equipment, that probably is a true statement, and it is a problem. One of the things that has happened with the use of risk assessment is what we call task-based risk assessment. And in task-based risk assessment, you look at the work that a worker or an operator has to do on a machine and the hazards he's exposed to during doing that work. For many times, people would build a machine and they would say, okay, you have to put a guard on here, and if you're going to do X, Y, and Z, the alternative is you're going to do lockout tagout. Well, if you have to clear a jam and you do it repeated times a day, you want to have safeguarding systems that protects the worker, not only when the machine's running, but also facilitates the worker easily doing his job. Example, clearing a jam. And I think as more and more machinery builders focus on task-based risk assessment, they're actually engineering better safeguarding systems, not better because the safety part of it's better, but better because it's a more easily allows the operator to perform the functions necessary. And by task-based risk assessment, you find these. If you only look at hazards on a machine, you don't recognize everything the operator has to do. Task-based risk assessment allows you to build effective safeguarding, and that's extremely important. If you want, one of OSHA's precepts is that if you have safeguarding on a machine that inhibits the operator's ability to do his job, he probably will bypass it. And that's one of the things you have to always be of concern with when you're engineering safeguarding.
Fred, thanks for helping us analyze and add some context to our survey results on machine safety. We're really grateful that you could share your insights in this market intelligence report.
Thank you for the opportunity, Jim.
For ControlDesign.com, I'm Jim Montague. Thanks for watching.